Happy Math Monday. Even if it's not a Monday, it's a Math Monday always.
Bruh.
Today, we're going to be taking the derivative of e to the x
to the e to the x to the e to the x to the e to the x to the dot.
So, how would you even start getting this? Since there's infinitely many x's and infinitely many e's. Alright, so first, you have to establish which way it's going. So is an e to the x all together to a bracket e to the x to a bracket e to the x? Or is it going from the top? So is there an e to the x, and below it there's an e to the x, and below that there's an e to the x, dot 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 to the bottom? This doesn't really make sense. And there is a difference, because if you look at this, if we use an example, 3 to the 3 to the 3 versus 3 to the 3, this one is 3 to the 3 to the 3, this one is 3 to the 3 to the 3, this one ends up being...
Bruh.
Oh my god!
Bruh.
To the 3. And this one is 3 to the 27. And this ends up being about 19.6 thousand. And this one ends up being 7.2 trillion. Which, my boys, that's way bigger. And if you use this one, it implies that there's an end, when really, we're going for a tall infinity boy.
Let's go.
Alright, brackets. We're going to be deriving this. So first thing you have to notice is this, all that, equals the standard e to the x, to the e to the x, to the e to the x, to the dot dot dot. Just that part equals that. So, which we can set it equal to y. It's our function. So, we can say y equals e to the x to the y. And then it'll have infinite recursion built in. Let me clean this board up. Okay, my boys. Then we have y equals e to the x to the y. We want to get rid of the e, so we want to take the natural log of both sides. So ln of y equals x to the y. We're going to do something a little crazy. It's not that crazy. We're going to take the natural log again. So ln of y equals ln of x to the y. And then using logarithm rules, we can take the y out in front. So the ln of y equals y ln x. And this is pretty good, because now we can just derive it easily.
That was easy.
So let's switch the sides. We're gonna derive this first using the product rule. We're gonna take derive, leave. So the derivative of y is just y prime, leave, ln x plus leave. We're gonna leave the y. We're gonna derive the x. So that's 1 over x equals, and then the ln of y.
The ln of y.
What does that equal? Well, first you want to get y prime, because you're taking the derivative of a y, and then you want the derivative of this ln right here, which is 1 over ln y, and then using the chain rule, the derivative of this ln, which is 1 over y, then let's clean this up a bit. Y prime ln x plus y over x equals y prime over y ln y. It's a little messy, so when we take it up here, let's multiply everything by y ln y. So then we'll get y prime y ln x plus y squared ln y over x equals y prime. Then we put all the y primes on one side, so y prime times
y ln x
minus 1 equals negative
y squared ln y over x.
Then all we simply must do is divide that into this side, divide both sides by y ln x minus 1. Then we get negative
Y squared ln y over x times y ln x minus 1.
and that should be the answer. However, there's y's in this answer, and we want our answers in purely x's. Because remember, our original was e to the x to the e to the x. So, remember that y equals e to the x to the e to the x to the dot dot dot. And we can rewrite this as y prime equals negative e to the x to the e to the x dot 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 all squared times the natural log of y, which we can just get rid of that e, times x to the e to the x to the e to the dot 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 over x times e to the x to the e to the x to the dot 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 times a natural log x to the e to the x to the e to the dot 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 times the natural log of x minus 1. And that, my boys, is the very tall derivative, the very tall derivative of an infinitely tall boy. Right here. And that's a good place to stop.